Okay, Year 11, I want to have a look at the next exercise 6.17. I know we've already done some of these questions using the T formula, but now I want to have a look at question 2 using Rcos theta plus or minus alpha, or R sine theta plus or minus alpha. And to use this formula to solve some of these equations in question 2, we have to remember on our formula sheet these rules. So on our formula sheet we get sine theta plus phi, and we know that that equals sine theta cos phi plus cos theta sine phi. And if we put the negative in there, that just changes that to a negative. If we use cos theta plus phi, and remember this is on your formula sheet, we get cos theta cos phi minus sine theta sine phi. And again, if you have the negative in there, it just changes the sign here. Now these two formulas are critical for doing R cos theta, R sine theta. So what we're going to be doing is we're going to be rewriting an equation as R cos theta plus or minus. I'm going to use alpha. I could use phi. Probably better if I did, but I'm going to use alpha. Or R sine theta plus or minus alpha. So let's try one. And we'll do 2b. So we've got this equation, 5 cos theta minus 12 sine theta equals -3. Now this is hard because I've got sine theta and cos theta. Now we know how to use the T formula to get one variable or get it all in terms of one variable, but this is another method and it's actually pretty cool. So the first thing is we're going to rearrange the left-hand side of this equation. But to do that, we need to have a right-angled triangle. And I'm going to do that again because that is just ugly. So let's take this right-angled triangle. And you make your short sides 5 and 12. It doesn't matter where you put them, just put them in. And I know it's not to scale, but that's not the point. So I've got 5 and 12. Now we use Pythagoras to work this side out, and we get 12 squared plus 5 squared, which equals square root of 169, which means we get 13. So now we'll multiply this side, this left-hand side, by 13 and divide by 13 at the same time. So we get 13 and 5 on 13 cos theta minus 12 on 13 sine theta. My pen's gone wonky, equals -3. I'm just going to fix that. That's just terrible. So we haven't done anything. We've multiplied this whole thing by 1, because multiplying by 13 and dividing each term by 13 is multiplying by 1. So down here in my triangle, where I've got this, what expression do I want to use? Do I want to use cos or sine? Well, the first thing and the most important thing, please remember this, is get your cos theta at the front. So we'll just rearrange this slightly. Cos theta times 5 on 13 minus sine theta times 12 on 13. That equals minus 3. Well, which one does it look like? Cos theta minus, it looks like cos theta plus phi. So let's write it as that, which means we've got to make the 5 on 13 cos alpha. So I need alpha to be there. And that will tell me that cos alpha is equal to 5 on 13. And sine alpha equals 12 on 13. So now I can write 5 on 13 and 12 on 13 in terms of sine and cos, and I'll be able to bring it all down. Let's just find out what alpha is. So alpha equals the inverse sine of 12 on 13. And I go to my calculator and I do that. And I get 67 degrees, so alpha equals 67 degrees and 23 minutes. We'll be using that later, so we better make sure. Oh, goodness me, I'm just going to rub that out because my pen's playing up. So I'll try again. 67 degrees in 23 minutes. So let's go back to our equation. And everywhere we see 513, we're going to substitute cos alpha. And 12 on 13, we're going to substitute sine alpha. So 13 cos theta, 5 on 13, cos alpha, minus sine theta, sine alpha. And that all equals minus 3. Now, we haven't changed anything. We've just rewritten it. But this is really good now, because if we look back, we can write all this in terms of cos, look up here, cos, and here we're looking at cos theta plus phi, or in this case, cos theta plus alpha. So we've got the 13, and we can write that as cos theta plus alpha equals -3. Well, let's divide by that 13. Cos theta plus alpha equals -3 on 13. And now we can treat this as one angle, and then when we find it, subtract the alpha, because we know alpha over here, and we can find theta, which is what we wanted to do. So let's go inverse cos -3 on 13. But before we do that, remember, all stations to central. When we do this, we're only trying to find the acute angle. The negative just tells us what quadrant or where it is. So we need to find the acute angle and go 180 minus, because that's where cos is negative, or down here, 180 plus. So if we find the acute angle, so we could just go, all right, theta plus alpha equals inverse cos. Now I'm going to leave the negative there, but when I do it on my calculator, I'm just going to type in 3 on 13, and then I'm going to know what I've got to get by going 180 plus whatever the acute angle is. So theta plus alpha equals, so if I go inverse cos, shift cos, 3 on 13, I get the acute angle, so I'm going to use a different colour here. The acute angle, I'm not going to use theta, I'm going to go the acute angle is 76 degrees and 39 minutes. So back to here, to find where cos is negative, I have to go 180 minus the acute angle and 180 plus. So it's 180 minus 76 degrees and 39 minutes. But it can also be in the other quadrant, so it can be 180 plus 76 degrees, 39 minutes. All right, so theta plus alpha, so I go 180 plus that, and I get 256.39, 256 degrees, 39 minutes. And if I go 180 minus it, I get 103 degrees and 21 minutes. We're almost there. We're almost there. I'm just going to fix that up just in case I make a mistake. So now I've got the answers, but I still haven't got theta. I've got to minus the alpha. So theta will equal, so just got to minus alpha. Remember, I've got alpha over here. So it's 103 degrees and 21 minutes minus the alpha, 67 degrees, 23 minutes. Or it's 250, theta equals 256 degrees and 39 minutes minus 67 degrees and 23 minutes. Okay, so let's do that first one, minus 67 degrees, 23 minutes. And I get theta equals 35 degrees, 58 minutes. And I look at the answers and go, your beauty, there's one angle. And then I go here, 256 degrees, 39 minutes minus 67 degrees, 23 minutes. And I get 189.16. Which is the other answer. Now you're going to think that's hard, but it's not that difficult. Let's look back at what we did. We had this equation. We thought, right, let's write it. So here's our equation. Here it is. Let's write it in another form. Let's get 5 and 12 as a ratio of sine or cos of an angle. We can do that. We just create a right angle triangle with 5 and 12 on the short sides, find the hypotenuse by Pythagoras, and then go, well, if this is a right angle triangle, cos alpha will equal 5 on 13, and sine alpha will equal 12 on 13. So we multiply this left-hand side by 13 and divide by 13 at the same time. That gives us 13 cos 5 on 13, sine 5 on 12 on 13. And then we just rewrite 5 on 13 is cos alpha and 12 on 13 is sine alpha. Divide by the 13. And now it's really easy. We inverse cos. We get the angle. We get the two angles in the domain of 0 to 360. And we subtract what we have for alpha up here, and we get the angles. I'll go over this again next lesson, but you need to try some on your own.